Understanding scope is such a critical part of JavaScript, or any programming language for that matter. It is an important foundation for building any code. Now, I know I have been throwing around execution context a lot, and you're probably sick of hearing me say it, but please bear with me a bit longer. We have talked about the global and function execution context. Well, whenever an execution context is established, a variable environment is established, and this helps define our scope. Now, you can think of scope as a set of rules that determine what referenced items, variables, and functions can be accessed. Let's first look at some important concepts about scope in JavaScript. First, a definition, and I promise this definition should help instead of hinder our understanding. And then some follow-up concepts that emphasize what that definition covers. So first, the definition. Scope refers to the visibility of variables or functions to the executing code. So basically, when we're at one line executing that line of code, what functions, what variables can that code access? In JavaScript, a variable or function is visible to the executing code if it is in the current lexical environment, so if that function or variable is in that current lexical environment, or the parent lexical environment. So now here's some important concepts we glean from that definition. One is scope is determined lexically. So where you define your variables, where you define your functions will determine if they are accessible by certain code, depending on where that code is in relation to those variables and functions. So what function is the variable in? What function is the function defined in? Those kind of questions help us determine scope, because those are questions about how things are arranged lexically. Now, JavaScript uses function scope. So a function creates an execution context, and that variable environment that is created with that execution context helps determine our scope. So JavaScript uses function scope. Now, this has to do with the parent lexical environment that was referred to in the definition. If a referenced item, meaning a variable or a function, is not available in the local scope, the engine traverses the scope chain looking for it. So we're going to talk about the scope chain, but that scope chain is referring to the parent lexical environment and that lexical environment's parent and so on. So there is a chain that the JavaScript engine uses to determine if it has access to a function or a variable. And this re-emphasizes that point a bit. Nested functions, nested scope, create that scope chain that we're talking about. All right, now to illustrate this, we need to look at some code. Now, I've used this code to illustrate scope a few different times. So let's take a look at it, and then we will walk through it. Now, as you can see, we have a variable defined at the top. We then have a function defined. Inside of that function, this is important, we're talking lexically now. Inside of that function, we have a variable. We have another function, add 10. We have another function, add 15. Inside of those functions, what do we have going on? Well, inside of add 10, we have a num2 variable. Inside of add 15, we have a num3 variable and a c variable. So we know that as a JavaScript engine begins executing this code, first a global execution context is created. And then each time one of those functions is invoked, a function execution context is created and added to the call stack. Each context needs to establish scope, which variables and functions can be referenced from inside that context. So let's look at that using this code as an example. So as we begin executing the code, we first assign a value of 10 to variable A. we assign this function to the variable add5, and then we get to this line which invokes add5 and passes in a number 3. So at that time we have a new function execution context created. Now when we get to this line where we're invoking add5, what other things do we have access to? Well, we have access to the add5 variable, which contains a function, and we have access to the a variable, which contains the number 10. So we can only invoke one function. All these other functions we don't have access to. They're not part of our scope. So we're able to invoke add5 because it is a function and we pass in the number 3. So that sets up another function execution context, and we establish scope for that. Within there, we have a num variable. We have access to that. We have a b variable. We have access to that. We have add10, which gets assigned a function. We have access to that. And we have add15, which gets assigned a function, and we have access to that. So that's our scope. But do we have access to more than that? Yes, we do, and this begins what we call our scope chain. So if we wanted to access variable a, we could access that. Because what would happen is the JavaScript engine would look within our local scope. We have a num, we have a b, we have an add10, we have an add15. Do we have an a? There is no a. Okay, let's go to the parent. We jump up. Oh, there's an a. I'll use that one. So that is the scope chain that we're talking about. Now, as we continue on here, when we invoke add10, notice what we do. We pass in a 3, and as this function execution context is set up, it establishes scope. We have access to num2, and notice we're accessing a. Is that valid? Can we do that? Yes, we can, because it will look for it in the local scope. It can't find it. It will go to the parent, which is this add5 function. Can it find it there? No. Well, it will go to the parent again. Can it find it there? Yes. And so it eventually finds it as a part of that scope chain and is able to use it. And so it adds 10 to 3, and we get 13 there. Now, could we from add10 right here, from this scope, could we access variable c? No, that is not part of our scope, and it's not part of the scope chain because it's not a parent of add10. And this scope gets established when add15 is invoked right here. And we pass 3 into num3, c is set to 15, we add those two together, we get 18. So we can see how scope is established and how it controls what we have access to, what variables and functions we have access to. And we can see also how the scope chain functions, how the JavaScript engine can traverse the scope chain looking for variables and functions which we invoke or which we want to access. Now, what happens if we don't have access to that? Well, let me go ahead and click on that HTML page and run this code. Let's see what we get right now. Just open up the console. 8, 13, 18. That's what we're getting from those console log statements. So 3 is passed in, so that's 8. 3 is passed in there, so that's 13. And then 3 is passed in there, and that's 18. So that's how we get that. Now, I mentioned, do we have access to C from here? Let's see what would happen, what the JavaScript engine does if something is not in our scope. And you've probably already guessed this. But if we jump out here, uncaught reference error, C is not defined. We've seen that error before. So when it cannot find something, it simply tells us that it's not defined. It's not a part of the scope. And since it's not a part of the scope, it considers it not defined. Now, let's take a look at a little diagram that illustrates the different scopes which we talked about with this code. Here I've color-coded the different scopes that are established. The outer one I've labeled A, and then inside of the add5 function, B, and then the add10 function, C, and the add15 function, D. Now notice that C and D both have the same scope chain because B is the parent to both. And so they both have access to variable B, but they can't access each other's scope. And they both have access to variable A because that's also a parent as well. So that is the scope chain. That is the function of determining what we have access to, what the code has access to when it executes, what variables and functions, which we call scope, and that's determined lexically based upon where we place things. Because I place this variable inside of add15, I cannot access it from inside of add10. And this also illustrates that JavaScript uses function scope. Each time a function execution context is established, scope must be established as well. We can see that in these examples here. All right, let's move on to the next topic.